Hello, everyone, and welcome to one of Digital Transformation's live series episodes. I'm Ali Soofastaei, an AI program leader in Valley. Our live interviews have been designed to develop the knowledge of applied data science and advanced analytics in different industries aimed to touch Industry 4.0. These live sessions are held every Friday with a professor of one of the universities, industrial managers, and experts in the field of Industry 4.0 and digital transformation. Today, we will discuss the application of machine learning in mining, and this is my honor to talk with my guest, Professor Victor Tenorio. Victor received a Bachelor of Science in Mining Engineering from PUCP and Master of Science degree from University of Alaska. He obtained a Ph.D. at the University of Arizona in Tucson in 2012. His research focuses on decision support systems and smart mining for optimizing productivity. Professor Tenorio has worked on several engineering projects in Peru and Chile. He is currently a professor at the University of Arizona, where he teaches Introduction to Mining Engineering, Mine Examination and Valuation, and Digital Mining. He also participated in the autonomous mining program with Freeport-McMoRan until December 2008, and he was program chair for the 7th International Mining Industry Summit on Business Process Improvement in 2015, and was co-developer of the Executive Mining Program for 2016-2017. From 2021, he's coaching Wildcat Moon Miners, a team of students participating in several competitions related to moon mining. Welcome, Victor, and thanks for accepting my invitation to be with us today.
Thank you very much, Ali, and thanks for the presentation or the introduction.
Thank you. So just to start the discussions and breaking the ice, what's the story that led you to your current role? What's your background, Victor?
Well, it started with my passion for computers, starting from personal computers and some code development that I did in the 80s. And at that time, there was nothing in mines. However, there was a few mentors that were developing ideas about computerizing the mine operations, because you were going to collect better data and eventually take better decisions. So I think that was the seed of this. And I would say that since then I started to go more into that direction, and that ended up becoming my not only my passion, but also the work that I am doing. And years later, when I decided to have higher education, I found the right people for that had the same ideas, and we're still walking in the same path.
Awesome. Awesome. So I was so lucky to meet you, but many years ago in person in Arizona. But I know that you are very active in some practical projects for industry, and you try to stimulate something in university, aimed to teach students better, and you can introduce a new technology to the students who are interested to start their career in the mining industry. That's great. Victor, always we talk about Industry 4.0 or talk about the mining 4.0. Can you give us the right definition of this word? Well, actually, what is the right definition of mining 4.0?
We can summarize the definition of mining 4.0 as the the new type of mining. Some people call it digital mining or smart mining. All of them are the same. And the name comes from the fourth industrial revolution. And that would be the origin of all these concepts. And fourth industrial revolution is a major game changer in not only in mining, but in the industry in general. We can talk about the first industrial revolution as the steam revolution and the industries that develop after that. The second one is electricity, or even we can go into transistors and all the changes that happened at the time. The third one, which was very important and is perhaps the marker of this, or the benchmark for what we are doing, is the computer revolution, perhaps the personal computer revolution, and how it became more reachable to people. Well, going along with that, the fourth industrial revolution is the utilization of computers, networks, and especially the utilization of devices, what is called the Internet of Things, that mark the difference between the third and the fourth, and its utilization for maximization or optimization, or even for safety purposes.
Oh, that's great. You already summarized everything from Industry 1 and reach to Industry 4. Maybe you have some idea about Industry 5 as well, but it's not in the scope of our discussion. Maybe later we can talk about what will be happen in the future and what's the definition of mining 5.0, for example. So, but Victor, a main part of mining 4.0 is analytics and advanced analytics, definitely. So, and we know that we need to use, for example, machine learning or artificial intelligence to reach to the better understanding and result. But what is the importance of applying machine learning and AI-based solution to mining business problems?
What has happened is that I like to start from the artificial intelligence side. And this concept was basically mimicking the human brain, the way the neurons work, and how some input data is processed and produces some output data. But it's not only that, it's the way that you can learn, or we can make this algorithms that you create or you assemble, learning things, and start with a set of data, and where they learn how how the process behaves, and then predict what is going to happen after that. So the only way to do this is by learning first and calibrating the weights and other elements of the other parameters of the neural network in this case, or could be something else like support vector machines that are a variation of it, and all of them learn in a methodology that is called nonlinear inference. Means that if I can infer with a straight line or a curved line or a square or parabolic line, is more or less something straightforward or simple. However, the nonlinear inference requires a segmented mode of approaching the results. But in that way, you can reproduce a potential result of some activity. And that is the essence of artificial intelligence. Machine learning is an evolution of that, and talks about machines that already come with technologies that are going to learn and calibrate themselves because they have incorporated the artificial intelligence features and based on the sensors that they have. And this is when the Internet of Things comes, because you can make these sensors provide the data that you require for analysis.
for many years, for example, in my organization, Valley, we used machine learning and AI approaches to solve the business problem that we had. But uh, sometimes we are facing with some critical challenges. For example, the data challenge is important because to train any AI or machine learning algorithms, you need a huge amount of accurate data. So having access to this type of the data sometimes is difficult in some cases. And another problem is the management trust. You know, we are working in an old industry, it's a traditional industry, and it would be
Yeah.
difficult to encourage the mine managers or so who people, the executive managers who can make a final decision to use AI. So we need to go step by step through this way to first making trust and all, and second, you know, uh, prepare all requirements that we need for AI and machine learning in mining. But Victor, let's talk about efficiency now because we are speaking about mining 4.0. We are speaking about the digital transformation. How does digitalization make mining operations more efficient? Well, we can talk about different aspects. For example, productivity, energy efficiency, safety, and environmental protection.
I think the mining industry or mining operations in particular are a perfect scenario for using these technologies more than maybe other industries. And this is because we work with data from the beginning, from prospection, exploration, all the drill holes and the core drilling and the samples and the creation of the models and then the operations and the control of different types of equipment or a number of trucks and shovels that are working, and especially the magnitude of tonnage that we're handling. In some cases, now the new mines start with 100,000 tons per day. Some of them even 1,000,000 tons per day in coal or in metallic mining, and and this is more or less the magnitude of quantities that we're working. So all of this is data. The topography and the update of this topography also is data. The control of water for dealing with the environmental protection, control of water, control of we can still talk about fumes or dust and other elements that also the reagents that we use at the plant. All of this is data that we need to control. And I will say at this moment that the most important thing that you can find in the controlling of this data is control or reduce or mitigate the variability of the results or the values that you have. In the good values, I mean, better tones, better quality, and other things, but also the bad values. I mean, pollution, contamination, or any other substances that need to be mitigated for the work of it. So, in general, we try to look after the entire mine as a uh, as a place full of numbers that we need to control and do what is required to avoid going away of the ranges and try to in the interim maximize our productivity.
Yeah, beautiful, beautiful. So, uh, based on my experience, digitalization or digital transformation in mining can help us to think about some multi-dimensional solutions instead of just focusing, for example, on energy efficiency improvement. We can talk about improving productivity as well or improving the safety. So having this type of the multi aspects or multi-dimensional solution can help us to think about the general optimization through the mine value chain, because previously we needed just to focus on one area based on the mathematical optimization methods that we had. But right now AI, machine learning, and other tools that we have access to them can give us this opportunity to think about multidimensional solutions and integrated solutions. So I think it would be a great tools right now in our hand to deliver the digital solutions for the business problems that we have, uh, in mining. So, but I know that we have different areas in mining that we can use digital tools for improvement. Okay, but what are the mining industry's most significant areas for using digital solutions?
I
Hmm.
I think I can say that um, the mine itself has several activities in the whole production process or the production chain. Sometimes it's called like that. And many times we tend as mining engineers to work only in what we know better, like is breaking the rocks and then moving the tons and delivering to our next client, which is the plant, the concentrator plant, or in the leach pad now for oxides. And we tend to forget that we are a full production chain. Okay, and if when we know better about the mining process, we have to see it from a different perspective, seeing everything in a holistic perspective,
Mhm.
and see them all as one is client of the other, the other is producing and delivering to the next client, and so on and so forth. So with this, we need to work hand in hand or elbow to elbow with the concentrator plant metallurgists, with the exploration people, with the environmental people, and so on. So all of these disciplines are linked, and one
Mhm.
needs from the other. In that way, you can create more integral views of this through dashboards, through big screens or several screens. In some mines, you can see that all of the disciplines converge into a single huge control room, for example, to see all the operations. And it's of the ingenuity of the developers that they will create different means of presenting the data in marquees, in dials, in dashboards, complete dashboards, colors, spectra, or whatever they want to use it for presenting these variations, but all of them together. And the final result will be the the uh, the uh, the entire benefit that we can obtain from the whole operation. And I'm not talking about just one operation. If we go back, we go to the headquarters or managers perspective, they may want to do the same with all the mines at the same time. So if you have 5 or 6 mines around the world, you need to do the same and still have the best values and the more accurate values possible.
Awesome, awesome. So, we in Valley we started the digital transformation program many years ago, I think 10 years ago. And we tested different digital solutions in different areas for different operations. For example, for exploration, for drilling, blasting, loading, hauling, crashing. So, but we found that, based on the experience that we found that we can reach to the better benefit when we focus on logistics projects. Maybe, for example, for maintenance or for hauling or for crashing, you can provide a digital solution, and it works very well, definitely, based on the current technology that we are using and the smart sensors, soft sensors, or many, many new tools that we have access right now in mining. But the maximum benefit of each type of this solution is $2 million, $5 million, $6 million per year. But when we talk about logistics projects, for example, using digital solutions for locomotive and railway, using AI and machine learning for vessel movement tracking, for mine material transportation, or focusing on AI-based prediction models for marketing or sales, you can think about the $1 billion saving and opportunity. So it means that now we need to think widely about the application of digital solutions in mining. But let's talk about some examples, Victor. I'm really interested in having some examples of maybe a couple of examples of how a digital approach, for example, can practically solve the business and operation challenges in mining.
One of the most notorious applications that utilizes the AI and the machine learning approach is automation, and I'm kind of is one of my favorites, but because I was involved in the development of some of these technologies, and they start first with first well, the first step is teleoperation, and then the autonomy. I mean that they have to work and basically move from point A to point B, doing a repetitive task, and in the meantime have special functions like, for example, collision avoidance or object recognition, or even lidar or other means of creating a cloud point of the path or they are following. So all these things become a very valuable thing. And one of the things that comes from that is that even though the original investment may be high, like for example, I have a $5 million truck and I want it autonomous, or it will cost you almost one extra million of overhead. But then you have to see how much extra production you are having, because you are again reducing the variability. The truck will work all the shift and all the day, uh, 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 always the same. In the meantime, uh, you you don't have this, like for example, the fatigue or the other problems that may appear that may reduce the capability of the system to optimize. The trade-off on this is that trucks work so hard that perhaps the maintenance go a little bit faster, and that would be the only thing. But in general, I would say to basically to summarize this is that the increase of production could go up to 10 or 20%, because you are using from the entire time. You don't have lunch times, you have breaks, and that's like 2 hours or even 4 hours during the day. So you can make these machines work better and more for you. And finally, the other thing is that also you're not exposing your people to go to into harm's way, or going in places where are unreachable because they are too far, too remote, too deep, or too hot or too cold. And instead
Mhm.
of that, you have safer operations.
Thank you, Victor. Yeah, I believe that we have many examples right now in different companies. We are using the digital solution, and I believe that you and your team in University of Arizona are pioneer in this area. I can remember many years ago when I visited the University of Arizona. You already developed a lab, name same as the remote operation monitoring system, and you could monitor the whole truck and some equipment uh, from university. So yeah, in that time it was amazing. You because I can remember we are studying at University of Queensland here in Australia. What is one of the best universities in mining area, but we didn't have access to the technology that you use in in Arizona. That's great. So let's talk about you know I can skip a little personal question. I know that you have worked in this area for many years, but what are some of the new digital technologies or innovations that you are particularly excited about?
Well, there's a few that attract my attention more than others, and I am very fond of them, and I also would like to see them working in full action. One of them is, and without mentioning names or brands, I would say that this is a technology that has total coverage of the presence of people and equipment in underground mines in live mode. Means that you know exactly where is this person working with what equipment and where is this person going, and it starts with entering into the mine, and even during the salutation, you are checked automatically with RFIDs and other, even with telephones or tablets or whichever, so they know exactly where you are and where what are you going to do, and you can have a full roster of people, a list of equipment, and all your plan can be done. These systems not only show you in a 3D fashion where people is and their machines and what tasks they are doing, but you can control their production or the productivity levels. But more important, one layer of advantage that we have with this is that they have safety features. So if there is a blocking or a fire, they can have immediately the escape route, and they know exactly where to take. If there is a jamming, a traffic jam in underground mines, it also happens, they can see it and they can be warned for this. So this is a great uh, innovation in mine tracking and personnel and asset tracking, and especially the safety part. That is one of the ones that is more interesting. The others are different sensors and actuators that, for
Mhm.
example, open and close the gates or the doors for ventilation according to exactly is the real air conditioning that we would like to enjoy in places, especially if they are too hot or so. Other things that are under development and are done here for mines that have this issue with the thermal gradient is sensors that could be wearable. You could put them in your vest or in your clothes and go into a mine and detect when it's too hot for a person and when this person must stop. Those are a few examples
Yeah.
of many that we can find.
Interesting, interesting. Thank you so much for sharing with us, your excited technology. So, Victor, I know that you have worked with Free-McMoRan, for example, or other mining companies in the United States, in Peru, in Chile, and you
Mhm.
are definitely familiar with the culture of mining and culture of company management. You know that it's little difficult to encourage them to use the new technology, because making trust is important point, and but it's difficult. Okay. uh, I'm thinking, how we can, for example, encourage the mining companies to invest in digital transformation. Do you have any idea, or what benefits have you seen in mining companies encouraging them to invest in digital transformation?
Um, there is a very positive trend on the way these things are considered for investment, investing in technology. I had a recent reading. And can tell in this moment the sources, but it's a very good, and I presented in some other conference about the investment in technology that companies are doing. And like 2 years ago or 3 years ago, it was like 2 or 2.5%. This year, and this is very fresh news, it goes up to 5%. Means
Mhm.
that they are doubling their interest in investing. And when I say 5%, is 5% of their revenues that
Oh.
they are investing in this. Now, this number is not necessarily for mining, is for many
Mhm.
industries that are using automation, and some of them, like they have continuous factories and other types of manufacturing, they require that, or they may need these technologies, like for example 3D printing now is a must, and they need to do these things. So this is a trend that is very interesting in this. And the other is that you can start small. It's not that, oh, automation in this mine, which is also 100,000 tons or whatever per day or more. And oh, this will cost us X million dollars, $10 million or whatever. It's too much money. Let's leave it. And many times it happened when we were talking and working with technology, when the price of commodities drop, you just put that in second degree of importance. But you can
Mhm.
start with small things. You can start with the Internet of Things and start with a small set of sensors for particular things. And I always keep the example of a friend of mine who always said he was working on an underground mine many, many years ago. And he was seeing that the pumps for the watering any body of water, they were so rudimentary that when they start to running on empty, they simply burn. Or if they go to they are over flooded, they also choke and burn. So
Mhm.
instead of that, you can have the same model, but they have a chip that senses when you have water or not. And that's your starting, the beginning of automation or technology for a simple thing. But then comes the other things that you can have: simple sensors, sensors in the scale, sensors in the doors, and other the types of detectors, and you start doing things. The important thing is that these sensors need to be developed or made for the internet, and that your internet system can reach these remote uh, uh, places in your mind
Mhm.
and bring back all this data, and someone in a control room or something can develop some analytics to take advantage of that. So you may already have the internet network, and you need repeaters of some sort, and then the internet devices that will bring this data into your internet, and someone who smartly creates the displays or the analytics required for that.
We talk about, Victor, we talk about the history of digital transformation in mining, and you explain for us what is happening right now. You mentioned some examples, but we know that we are living and working in the era of weak AI. But in the close future, we will move to, for example, general AI and strong AI, and definitely we will have access to more accurate sensors, and we can make some decision making system based on artificial intelligence, etc. What are you most excited about the future of digital transformation or digitalization in mining?
I think we will see more of these technologies applied
Mhm.
into common or normal operations. That's the first thing. So we have now autonomous trucks, and perhaps in the future we may have autonomous excavators or other types of equipment for doing that. We already have autonomous drill rigs, so it means that I can leave an equipment and do drill on the entire bank for the next million tons of the
Yeah.
month. And that's a very good thing, and it's becoming more and more accurate. But also there's other aspects to cover. For me, some of the most exciting and the first that come to my mind is the visualization of the ore bodies. And I've seen a few
Mhm.
examples with using virtual reality, basically, and you kind of touch the touch the ore body and say, oh, here
Okay.
it is, the richest part. And so, and that's one. The second one is uh, the well, one of them is blockchain that is associated with
Mhm.
the entire mining process. And
Ah.
I'm talking not only mine to mill, but it could go more than mine to port, or even the biggest one that Dr. Fonton used to mention in her lectures, and is a mine to market. So
Oh,
we kind of control the entire thing, or adjust
mine
to
value
the
chain.
Correct. That is a good thing. That's one of the things that I like more. The others are new technologies that are very valuable. For example, I like augmented reality. That's very good for training and for fixing things, especially underground. If I have a mechanic shop underground, I can see with my uh, uh, goggles or any other way, or sometimes screens in a tablet, the piece or the spare part that I need to fix, or the piece that I need to fix, and fix it or replace it or order it directly there, and it will come soon. So these are other things that will be good. The others are the seeing the mine as an entire manufacturing process is a thing that I was thinking for a long time, and everything should give you an index or indicator of if the entire whether the entire mining process is going well, or where do you want to fix things. Those are a few examples of things that may be coming soon.
Perfect, perfect. So, Victor, we talk about some benefits of digital transformation or using digital solution, AI or something like that, a new technology in mind. But as you know, each coin has two sides. Okay. So, as the last question, I want to ask you about some challenges and limitations that we have. What challenges are mining companies facing using digital solutions?
I think is an unfinished business that needs still to be ironed out and understood completely. There's still a reluctancy, and this is kind of a natural feeling on people, saying that we're kind of working against robots, or I mean, facing. I say robots, but it's not like that. But it's a huge autonomous truck
Mm,
is a robot on tires. But yes, some of these things there's always the fear that you may be losing jobs, or that is a robot against persons, or other things. Those still exist. The other is that some of these solutions are long term.
mhm,
And if I say, oh, I want my mine and my plant all automated and all autonomous or smart mine, it's not going to happen tomorrow. It's going to happen in several years. And it also requires some investment that it has to be adjusted according to the market, the commodity prices and other things. Sometimes also is the quick obsolescence. Oh, I have all these my sensor. Yeah, but that's version 2.x, and now we are in 4.x, and you have to go back again and buy more and more. This is not talking with this one and the other. And the other is the diversity of technologies, and because of that, it may take a while to make them all compatible or talking to each other. So you may have several uh, uh, solutions for things, and still take some time to make them all together. Some of them are working, like for example, have one type of computer that has space for several different technologies. So you may have, or either I don't know if you can have everything in a common screen, but perhaps you still have several screens. That was at the beginning with the technologies of fleet management systems, that you have this brand and this brand and this brand, all of them in your truck. And so you have to
mhm.
see, you
I
have to
see.
see several sources of data. So you have to be more tactic and create simplified um, screens with just a few colors and a few symbols to simplify things and go beyond that. The others could be perhaps other means of visualization, like heads up displays, or some other things, and others that you don't not even see. Is like a new car. The new car is telling you, oh, you have this in the tire, and you just see
Mhm,
the tire when it happens, or the engine needs oil, and you see the oil figure only when it happens, not all the time. So that's a simplification to the max. So we have to see some of these things already incorporated into that, and make them easier. Otherwise, there will still be a time to. There's a few questions here. Anyway,
yeah.
there will be. a few times for to rethink the ideas that you have to kind of do them again or request them again because of obsolescence or because of the change of nature of what you're doing, or perhaps something better has come, a better version of this and that. And finally, the cloud technology is a great thing that is helping solve many things, because if you have sufficient space, sufficient virtual machines working in your environment, and sufficient storage space and so on, you can have the big data. You can have your data lakes that are very valuable for, in one way are valuable because you have everything there, but on the other hand, you have to be skillful to extract the best of it and do it. So it's a continuous learning and a continuous process that is happening.
Perfect. So uh, I really appreciate, I really appreciate, Victor, for your time that you spend with us. You have two questions, and both of
Yes.
them are about the autonomous fleet. The first one is, I think Timothy asked about are the truck loading automated as well? So I think he asked about the fully automated loading system or something like that. Could you please answer this question?
Yes. I haven't seen full developments of the autonomous loading. This is mostly because we are thinking on the equipment as it was. So we have a truck, and now we are seeing variations of this truck even without a driver's seat, which is the first step. But with the shovels or the loaders, we don't see that yet.
Mhm.
I have seen some equipment developed in Germany, but it's still in experimental or prototype, that has its own auto loading system. It's a sort of I'll call it a rack of some sort with some buckets that go in at the back of the truck, and they go and collect the data from the stockpile. Sorry, collect the rocks from the stockpile, which is also data, but and then put it on the truck bed automatically, if not autonomously. So this is a mechanization of some of a manual process of or mechanical process of loading a truck, but it's very difficult yet to replace a very skillful shovel operator. These guys not only do, yes, they do repetitive things, but at the same time they think, and when they dig and have some resistance, they do it in a different way or so. That's a thing that it cannot be replaced by a machine yet. And also the interaction between the shovel operator and the person and the driver, the truck driver, is something that is being lost because of the and the, of the autonomous technologies. And it's like working, I say, working with Sleepy Hollow. So you don't see the head
Right.
or the face of the truck driver, and sometimes there's a reluctancy that you need to address. So these things haven't been solved at all. So unless there is a continuous thing that it may go, for example, into coal mining, perhaps, and you have continuous miners that now open or do the stripping without human assistance. And you may have a machine that I have seen also in coal, which is capable of cutting, and loading to a neighboring truck of some sort, going together in convoy. But uh,
Mhm.
I think it's for a very specific type of mining, and we have to see more of that in other
Yeah.
with other commodities.
Thanks, Victor. And we received a very good question from John. It's a question
Uh,
in all conferences that I attended is a key question, because the mining companies already invested for the non-autonomous fleet. You know that one truck, maybe the cost of one truck is between $3 to $5 million. It's not easy to change everything if we are looking for the autonomous fleet. It would be very
mhm.
difficult, and it's a huge investment. So the question that we received from John is about upgrading. is there any
Mhm.
chance to upgrade the non-autonomous fleet to the autonomous fleet, or we need to start from scratch and make a new fleet?
Well, actually, what happens is that the first move to going to autonomous is using your existing fleet, and
Mhm.
that's kind of a sales pitch when they say, "Hey, you have let's say 30 trucks here, and now you want them all autonomous. Okay, I'll give you a price. Okay, the prototype has been developed somewhere else, and I can give you for $500,000 each unit. You can have the technology." Like a piggyback on your truck, plus the infrastructure, a few tweaks on your infrastructure, and you are autonomous already. But you have to do also some change management and educate the people, relocate the workers that were actually driving the truck, and they have to do other things. Perhaps will be the supervisors, operators, or manage the dashboards, or do something different. It could be kind of a scaling up to something, a better type of job.
Mhm.
So that is the first part. And it's better than trying to replace them all with new equipment. Sometimes you cannot do that so easily. Now, if you are buying from zero, the new trucks in several brands are coming already autonomous and without the driver, driverless, or without even a steering wheel. And some of them look very, very strange, but at the same time very practical. And perhaps that will change the mind of the people who thinks that every driver's seat is a job opportunity. Not anymore. I mean, there will be other things. And also, just to round this idea, is that we're going to farther and more remote places and deeper places and under harsh conditions. And talking about the moon, we will be teleoperating all the equipment and doing the mining from a safe position, perhaps the gateway or a space station or the the bright side of the moon instead of going to the South Pole, which would be much more difficult. So we need those machines, and also underwater. If we go mining underwater, nobody can go and fix the thing at 1,000 meters or deep or so. So it's impossible. So we need to make them more actually autonomous, even self-repairing. That's some of the things that we have seen in Mars, in one of the rovers that got stuck in a rock, and came the sandstorm and covered the solar panels and didn't work anymore. The next generation of rovers came with an autonomous function of dislodge themselves from the rock and being able to continue their work. So some of these things can be done. It's happening with some cars now, that they can park by themselves, they can brake on time in front of a person, and a few other things that are a very good development for the modern times.
Awesome, awesome. Thank you so much, Victor. You did a great job, and it was one of the best interview that I had. I really appreciate. We are at the end of the interview, and once again, I need to take this opportunity to thank, yeah, you to join us in this episode, and also all the participants in the live session. The recorded version of this program will be available on our YouTube channel and other virtual pages on different social platforms. Thanks to all of you. I hope you have benefited from discussed topics, and hope to see you again at the next event. Thank you so much, guys, and have a lovely weekend ahead. Thank you.
Thank you very much. Thank you very much, Ali. And good. Also, goodbye to all the audience, the live audience, and the future audience when it's been posted.
Thank you so much. Bye-bye.
All right.
Bye.
Bye bye.